Alright, so today we're going to look at how to cross multiply. So if I write this down here, cross multiply, and we're going to do a how-to. Okay, so when I see students cross multiplying, I see a lot of the same mistakes. And one of the mistakes is, let's just write down the algebraic equation. So let's go 3 over 2, which is equal to x over, let's say, 4. Okay, and cross multiplication, a lot of students look at it and say, well, I'm going to bring my 2 up and across here, and my 4 up and across here. Okay, which is completely possible, but we'd like to take a step back and look at why you're going to do this. So this is an algebraic equation, and our solution should look like x is equal to some value here. Okay, so we have some value here in the end, all right? And if you notice, there is a hidden 1 underneath this x, meaning x is a whole number, all right? So if you take any value and divide by 1, you should get that value. So it's okay if I write a 1 in front, or pardon me, underneath here. And if you look, there's actually a 1 multiplying the front here as well. So if we go 1 times x, we should get x as well. So we have a 1 in front of the x that's hidden, and a 1 underneath this x that's hidden. Okay, so this is what we want to look what our final answer should look like. And if you look at this current equation, we have a 4 underneath here, so this 1 is not here. And if you look here, we actually do have this invisible 1 in front of here. So this here is perfect for our equation, but this 4 has got to move. Okay, now if we bring the 2 up and across here, okay, so imagine I wrote that and I cross multiplied the way that lots of students do. You would bring this 2 up and across the equal sign, and it would be there, and you would have the 4 up and across the equal sign, so that would be multiplied by 4 here. Now if you do that, now look at this, you have this 2 in front of the x, and you no longer have this nice 1 here to solve for x. So what you would need to do is divide out the 2 again to cancel. And if you do that, what happens is you end up with the 2 exactly where it originally was. So cross multiplication, we're going to look at the rules again. So let's say I take another example. I'm going to use this one here. I'm going to say, let's say 4 over 5 is equal to x over 7. So knowing that there's a 1 in front of this x, using this idea here, alright, I only want to move this 7 up and across. I don't want to bring this 5 over. And cross multiplication tells me that if I would like to, I can bring any one of these numbers. So I'm going to write it in a little block. So my x is in a block, my 7 is in a block, my 5 is in a block, and my 4 is in a block. And at any point, I can bring my blocks across and over from one side to the next. So that means that if I would like to, I could bring my 5 up and across. I can bring my x down and across. I can bring my 7 up and across. Or I can bring my 4 down and across. And I can do these any which way I would like. I can choose one, or I can choose all of them. But we would like to have x on our own here. Again, remember that we want a solution that looks like x is equal to one of our numbers. So if that's the case, and cross multiplication allows me to move these blocks one at a time, I can just move my 7 up and across here. So now I'll have 4 times the 7, which is moved up and across. And I'm going to keep my 5 down here, and now I've actually solved already for x. And in this case, 7 times 4 is 28 over 5. So it becomes an ugly fraction, which we just can leave it as that. Okay, so let us try one more, but it's a little bit more difficult. So imagine you have 3 over 4 is equal to 2x over 6. Now in this example, if we look at it, we do not have a 1 in front of the x, like so here. And we do not have a 1 underneath the x, like so here. So if this is the case, we actually have to move more than one block. So if I want to solve for x in this case, so it's x is equal to our number, I need to move the 6 across here. And this 2 stuck to the x, I have to move him down and across, so that x is by himself. So if I do that, I now have x here. My 6 is up and across, so I have 6 times 3. And I have 2 down and across, which is 2 times 4. This way, I've done cross multiplication correctly without any extra steps. So 6 times 3 is 18, and 2 times 4 is 8. And this can be reduced if we'd like to. So we can reduce this. A common factor between 8 and 18 is 2. So 18 becomes 9, and 8 becomes 4. And that's our solution, and how we can keep cross multiplication simple.